So first, let's hide everything and open our instance sources collection and add a new collection called planks. Now I'm just going to enable my character so I can have some size reference, and let's add a simple cube to begin with. Scale it so it's about a feet wide and a bit thinner. Now add some edge loops so we will be able to add some deformations to the planks, and I want to add the ridges on one side, so I will add a bunch of geometry on this side. Change the size on the z-axis, and we have some ridges. Apply the scale if you made any change to that. Rename this plank and add some materials. Right away I will also change the viewport display color and duplicate this about 5 times. Now let's select all of them and apply some slight deformation to everything. I will also add some cracks on some planks. Now let's add a bevel modifier to everything, set shade smooth, and copy this to every planks. Now let's add some shading. I also made some wooden beams in the same way with the same materials, and those are exactly 1 meter long, which will be useful later to scale them as we want. Everything is based on a noise texture, which is squished along the y-axis, so we get some elongated grain, and it also goes through a color ramp to crunch a bit the values. And as I am using generated coordinates, I am using the object info node into a multiply, and this allows to get different values for each planks randomly. Then this drives a mix node to blend between 2 different brown colors, which I am adjusting a bit, and then making 2 variations, one really dark one and one lighter. I am using an ambient occlusion node through a color ramp to blend between those 2 values, which allows to get darker values in the cracks. And the bump node before the ambient occlusion node, which is set to only local, also allows the grain to affect it. With this color I am also making a second variation which is desaturated and a bit greenish, and to blend between those 2 colors, I am using a second ambient occlusion node mixed with a setup which allows to select the underside of the planks, so that when the planks are occluded, for example like this, we get a different shade, which will give a really nice effect when the bridge will be made. Then I use a second noise texture along with the first one to drive the general bump of everything, and the second noise is also driven by the occlusion, so we get a kind of dirty effect when everything is occluded. The planks are set up with a bit of roughness and no metalness. I also made this quick look depth view so you can get a better look at the materials and the setup for the planks and the beams. Now let's implement this in our terrain. The subtle thing being that if you want a bridge, let's say on this section, the bridge itself and the collision will have to be straight. So we'll have to override the collisions and the slope detection and everything in order to not use the noise, but a single straight line on which we will instance the different planks. After this, we will also generate some support for the bridge and some railings, all this procedurally using the planks we just generated. For the base mesh of our bridge, we are going to add a simple curved line. The start point of our curve will be the chunk size divided by 2 on the y-axis, and for the endpoint it will be the same divided by -2 on the y-axis. As usual, you can set a named attribute to call this the bridge, frame everything with Ctrl-J, and label this bridge curve. We can join this with everything else, and now we want to know on which chunk we want to change the biome to the bridge. For this we will need the chunk ID of every chunk, and more or less its simulated ID. For example, if at the beginning the chunk ID are 0, 1, and 2, and once we move on and the chunk 0 is going back around, the chunk IDs will now be 1, 2, and 3, with the third chunk being the old 0 chunk because we are moving it around. To do this, we'll add a new named attribute node on our base chunk. So in the initialized chunk frame, we can duplicate the store named attribute node and call this chunk underscore index. Set it to integer and plug the index into this. The easiest way I found to compute the fake index of every chunk is just to scale it with the value we use to compute the noise. So right here, if we take the y value before converting it to a vector and dividing it by the size of the chunk, this will give us an index. We can test this very quickly. So for example, at the beginning, the index are -1, 0, and 1 because it's dependent on the position. So to correct that, we can add just 1. Now we have 0, 1, and 2. Now if you are moving a bit, the index will now be 3 for the old 0 chunk, which is what we want. Then we have chunk 1 and chunk 2, which is perfect. So this is the fake chunk index, which we can store as a named attribute right after our simulation zone. To randomly select chunks on which we want the bridge to spawn, we can take our named attributes for the index, plug this into the ID input of a random value node, set to float, with values between 0 and 1. This combined with a threshold, which we can adjust, which will allow us to choose the probability at which we are spawning a bridge. So for example here, if you are visualizing this number, if you want a probability of 0.1, then the chances of a chunk spawning a bridge is about 1 out of 10. Here we have our first bridge, and a second bridge right at the end. So this is the first way with which we are going to select our chunks. We also don't want it to spawn when the slope is too great, because that wouldn't make any sense. So let's also add a way to discriminate the chunk by its slope. To get the slope, we only need 2 points. Luckily, we just added some splines for the bridge, which only has 2 points. So let's get this geometry right before we merge everything. Separate geometry, and with the named attribute set to bridge, we can get our splines. From this, you can use a simple index node set to vector to sample the curve tangent. And for the index, because each curve has 2 points, so we can take the name attribute we created before, source chunk index, multiply it by 2, and like this, we'll have a single point of each spline for each chunk. Set this at the index. Now that we have the tangent, we can align Euler to vector, and set the sample tangent as vector. And just like the slope to determine the speed of everything, we can separate x, y, z to only get the angle on the x-axis. Now before, we sampled the normal, which we compare to the z-axis to get the angle of the slope, but here we are sampling the tangent, which is basically like this for every spline, so we can compare it to the y-axis. And now, to know if everything is flat or not, we can compare this with the compare operation, set to float. For the b input, you can type in pi, and for epsilon, you can add a math node, which will be set to 2 radian, so you can input just a simple angle value, which will act as the range of angle we want to treat. So this is plus and minus 5 degrees, because we are centered around the pi value. So here, if I want to compare plus and minus 10 degrees, we have to multiply this by 2. Here in white are all the chunks that satisfy this condition. Now, if we compare that with our probability-based chunk selection from before, we can add an AND operator. And because we removed quite a huge number of chunks, we can higher a bit the probability, so we can frame everything here, which will be the bridge chunk selection. Now let's move everything over. So we can add a store named attribute node. The name will be the biome. And here for the bridge, if I set this like this, we will have a biome index of 1, and we can set this to integer. So now let's start to spawn our bridge. This time we are going to work under everything. First, add a separate geometry node. We set a named attribute as a bridge, and we want to delete everything if the biome is not equal to 1. So right here, we only have our spline for where we want to spawn a bridge. Now we can bring in our instancer as usual. The name will be bridge, and the collection will be our planks. Right now we only have 2 points, so let's add a resample curve node set to length. Let's set all the scales as at 1 for now, so we can have a better look at this, and adjust the resample lengths so all the planks are evenly spaced. To see how it looks on every chunk, let's temporarily disable the delete geometry node, and let's adjust the rotation. Take the curve tangent into an align vector to Euler node. Now we just need to set the rotation to Y, and this is already looking like it will work. Let's vary a bit the scale. Now we can also plug the master scale, just like the other nodes, into our node here, so the road is forming like this. And before moving on to finalize the bridge, let's fix the collision and remove the ground beneath the bridge. So to move the ground beneath the bridge, we can just add a set position node right before everything is branching out for all our instances, but let's just separate the flow for the collisions, like this. Now with our set position node, we can control all the instances like this. For the selection, let's add a named attribute and make sure we are not moving the bridge. Now we want to simply offset everything which is right under the middle of the bridge to have kind of a slope like this, which will be quite simple to implement. First, we need to know how far we are from each edge of the chunk. To do this, bring in your named attribute for the local position of each point and separate the x, y, and z components to get the y position. Now we can remap this from the extreme values of the chunk, which are plus and minus chunk size divided by 2, so chunk size divided by 2 and chunk size divided by minus 2. And if we plug this into a float curve, we can get somewhat of a bulge like this. Let's plug this into a mix node to mix where the value is 1 between a value of minus 1 meter and when it's 0, let's keep it like it is. So let's combine this x, y, and z into the input and plug this into the offset of our set position node from before. Now right now we are moving this everywhere, so we need to combine this filter with the bridge biome. So let's get our biome index and compare it with the value of 1. Now if we add a math operation boolean and to combine those two filters, we'll have something like this. And let's just move on to a point where we have a bridge. Right here we will have our first bridge. So remove the delete geometry node from our bridge from before, and let's see how it looks. It just seems like the -1 value isn't strong enough, so let's put everything down 1.75 meters. And let's fix the collision. Let's go back to our bridge. So here, if the biome of the chunk is the bridge, we need to push down the collision and slope meshes so they are matching with the bridge. So let's do this right after we are merging everything. So let's tidy this up a bit. First, add a set position node right after the merge by distance node. Again, we can move everything aside to have a bit more room to work. So first we want to apply this only either on the slope mesh or collision mesh, and only where the biome is a bridge. Then to compute the position itself, we will need the spline of the bridge, which you can resample so it has as many points in one direction as our chunks. So with the group input, collision mesh resolution. Now the easiest way I found to flatten the collision meshes is for each point to sample the closest point to our spline, compute the z position difference, and adjust for it. So to sample the closest position, we just need a sample nearest node along with a sample index node. Plug the index right away. What we want to sample is the vector, which is the position, and we want to compute the offset with the original position of our collision meshes. So we need to subtract those two. So we want to put first the target position and then the source position. And now, so we need to clamp this offset only on the z-axis with the vector mass multiply node set to only 1 on the z-axis. And finally, we can plug this into the offset input of the set position node. And let's not forget a very important detail. The sample nearest node doesn't work with curves. So we first need to convert this to a mesh with a curve to mesh operator. Now if we inspect our results, everything is correctly flattened. Let's see how it looks in the animation. our collision mesh is correctly flattened. Now the sides of the slope are maybe a bit too steep. Let's tidy up our node setup with our bridge collision flattened. Now let's go back to our bridge setup, let's display it everywhere, and let's finish the building of it. So right now we only have the planks on the ground. So we may also need supports and then railings. For the supports, I want to instance everything at the middle of our spline, which is generating the bridge. So to get this point, we can resample the curve with 3 points and delete everything except the middle point by selecting the endpoints. So we only have a single point in the middle. On this, we can try to instance a first plank, which would look like this. So we need to correct its orientation. So before deleting the geometry, we need to capture the tangent attribute, which is a vector, and we can put the curve tangent. With this attribute, we can first add a rotate Euler node set to axis angle, so we can rotate the planks by 90 degrees around the z-axis, and now use the curve tangent with the align Euler to vector node as usual, where we will set our captured curve tangent as vector, and if we keep it like this on the x-axis, the curve support are instanced just like we want. Now we need to fix the scale of the planks. On our instancer, now I can use our new beams collection, and I can add a scale instances node. We can just put roughly the width of our chunk on the x-axis, with one on the other axis. Let's join this with our planks to see how it looks. And let's also plug our master scale into our instancer right here. So before moving the plank below the deck, let's make sure there are 2 supports. So for that, add a simple mesh line set to endpoints and with 2 objects. And right after the delete geometry node, we can add an instance on points node, with the instance being the mesh line. Let's realize this instance, and sure enough, we have 2 beams. Now we need to adjust those locations so they are side by side. In my case, an offset of 0.65 meters works well, and I can also transform it so it's a bit below, just like that. Now to add some railings, it will be the same. You can duplicate this and join this right here, just offset this above, and we can also spread them out just slightly. So there will be rooms for the railing supports. Now let's try to make this a bit less messy. Let's just select all this and remove what we don't need. So first we won't need both levels of the handrails. So let's remove all that. Then the scale will be input manually. And for the rotation, we don't need it to be aligned because we just want it to be vertical. So let's remove all that. So I rotate it only around the y-axis and resample it by length. Let's join it with the rest to see about the scale. So we need it to be way shorter, and we can also make it slimmer. Now for the location, we can move it aside, around here, and we need to offset it to the top, just like that. Now we can also fix the position of the top railings, which are those 2, but just barely. Let's just resample the planks a bit tighter, and we also need to plug in the master scale everywhere. Now here is the bridge instance everywhere. If you happen to have 2 bridges side to side, there will be collision issues, so we also need to remove the first and last planks, which we can do the same way we did here with an endpoint selection and delete geometry node before the instancing. This way we won't have any collisions. Now if you enable the delete geometry node, and let's look at the end result. Let's run it until we find the bridge. And that's looking really nice. Let's see with the collisions. The bridge planks are a bit too high, so let's lower everything. And that's it for this video. Hope you learned something here. In the next part, we'll continue in this direction in order to add some trail signage and some procedural trees. Feel free to reach out to me if you have any question. Thank you for watching and see you next time.